That said, rather than jumping into find grape just yet, I'm going to just realize that, okay, if there is a grape, okay, well, we can go ahead and do that. That decision point is going to be really easy to determine based on what happens when we call find grape, right? Because we've currently said that this is null, right? There's nothing in here. So it seems pretty easy to me to just say, if we didn't find anything, right? We didn't find a grape anywhere, well then we'll just leave these coordinates null. Because there's no information to pass around, right? There's no x, there's no y, there's no row, there's no column. So we can just have nothing. So in this case, we will say, whoops, let me come down here. So if, and then we know that we have an else. So what we're saying here, so if there is a grape. Now, you can work your logic one way or another. So if we say if grape equals null, all right, and this is a comparison that we can make, we can ask if the object grape has any meaningful memory address. Right? So if the grape is null, and we'll just change this comment, and then we'll come down here, and we can just cut that, come down in here, and then paste it. Okay, and then we'll move, and I'm going to back up just because I'm going to take this comment and move it here. So I did change the language on these a little bit, but one thing that I recommend about pseudocode and how you can take advantage of your own pseudocode as you're writing stuff out is, cut and paste it and put it into the right place. It also means if you had sort of like a checklist, as it were, in your pseudocode, then by cutting it from down here and pasting it up here, well then you have the sense that you've got it covered, like you've done that somewhere. Whereas if you just duplicate everything up here, as you had down here, then you might miss something and not realize it for a while. So anyway, if grape is null, we're going to get a random move. Otherwise, that means that we've populated grape, we've created a new coordinates object down here in find grape, we've handed that back so it's not null, which means there should be some useful coordinates. So in that case, we're going to figure out all this other stuff, right? We're going to figure out how far Oscar is to the grape. And then, there we go. And then we're going to move in that direction that makes Oscar feel warm and fuzzy inside. And that's pretty much it. And as you see here, I've got like some extra space and all this kind of stuff. It doesn't matter. In fact, when you're writing stuff out, if it helps you to, say, put an extra line before, let's say, your if statement or a loop or something, that's fine. You can break it up visually however you want so that when you look at it, it makes sense to you. And you can see that BlueJ is kind of helping us out a little bit with this syntax highlighting by, all of this entire if statement is purple. And it'd look a little more, see, it kind of fills it in if, if my comment wasn't back there. I just had my comment lined up with my other if statement. However, it is also equally viable to do this and put your pseudocode for that branch of the statement just inside of it. So it's indented with it, and it lets our purple continue down. So we can see, if there is no grape, we're going to do this stuff. If there is a grape, we're going to do this stuff. So we compile that. There's no problems. So we can actually, back up one more thing here. So we have yet to change this. There we go. So without changing this, our move would never change, right? We'd never do anything different ever in the universe. We would always just go north, which is not what we want. Okay. So now move gets initialized to north, which is totally fine, then we're going to see if we can find a grape. We know that we won't. We haven't figured that out yet, but if we didn't find a grape, well, then we'll get a random move, and we've already dealt with getting a random move, so we know that that should work, right? And we don't have to worry about any of this stuff because we know it's not going to happen yet. So we should now, if we instantiate a new Oscar, let's ask us for a name, we come in here, so now we can say get move. And we can see here the Oscar coordinates, find, grape. So we're seeing all of these methods that we've created. So if we do find grape, it's going to ask for the board. And this is a great place to introduce that if you want to test how your Gobbler behaves in a specific circumstance, right? You have some tiny representation of a board, like a 3x3, and you're wanting to give it a specific scenario to see how it's going to respond, and if it's responding in the way that you expected, you can actually pass in an array that you create on the fly. Not super useful with this little teeny form, but I'll show you a better trick in a minute because I don't think I can open that up. But if you remember from the class notes that the set notation for initializing a brand new array is curly brackets, and then all the things inside of it are delimited by commas, okay? So our board is an array of arrays of characters. So the board itself is one list, right? So it's one set of curly braces, and then inside of it will be each of the rows, right? What each row represents will be the thing inside. So in this case, each thing inside is an array of characters, which means that each one of them has its own curly brackets. So right now, we'll do that. So what I have is a 1x1 with a G in it. That's it. So the outer one says I've got one row. The inner one says I have one column. So it's just a 1x1, which is not very interesting, but it is technically a two-dimensional array of characters, and we can pass it into this method. So when we do that, because we didn't do anything special with the board yet, all we did was return null, that's what we see. So if you see Oscar coordinates null, then you should know that that means that that object is empty. There's nothing allocated, there's no row, there's no column, there's nothing. It's empty space, but we anticipated this. I just wanted to show you what that was and a little bit about how you could pass information into it. But I'll show you something better later that lets you do more interesting stuff. However, what we wanted to really do was test get move. Now again, we're going to have to pass it a board. So in this case, I'm going to do exactly the same thing. It's a very uninteresting board, a 1x1, but it's technically valid, right? Because even though you know as the person writing the algorithm that the board is generally set up as a 20x20, your Gobbler on a turn-by-turn basis has no idea how big the board is. At least not to begin with. It receives a copy of the board, and then it uses that board to make decisions. So while it isn't going to happen, it would be theoretically possible that the board that is handed to your character on each and every turn isn't even the same board. Like, it has nothing to do with the board from the turn previous. The game doesn't work that way, but it could. So anyway, we successfully called it though. We gave it a board, and it returned a valid code of north. So that's just to show you that everything that we've done so far is actually functional, meaning it didn't crash, it didn't explode, Java didn't give us an error, we didn't have any problem. It didn't actually fulfill our algorithm yet, but it didn't break anything either. So this is good. This is a good, steady way to move forward. So by being slow and careful and recompiling and kind of testing little bits and pieces as you go, it makes things way easier than if you attempted to write a whole bunch of code all at one time and then tried to compile and then tried to test. Because when you run into problems and something doesn't work the way that you expect, especially if you have syntax errors or there's other problems with the code itself and you can't get it to compile, it becomes way more frustrating to try and figure out how to resolve, a bunch of different compilation errors, because sometimes they can sort of hide one another. In other words, the one that it's complaining about in that moment might not be as obvious as you would want it to be, and when there's fewer potential errors when you compile, the more likely it is that the problem that it tells you is one that you can recognize and fix, right away, versus trying to wade through a whole bunch of problems all at one time. So at this point, we have got a single method to find a grape on the board, which we haven't implemented yet, right? We haven't transferred any of our pseudocode into that, but it's there and it's handled. We have our condition, right? Our big condition of if we find a grape or we don't find a grape. So now, if there is a grape, we have some stuff to do. But so at this point, what's inside of here would probably be much easier to implement. Like it's not as complex. Like when you come down here, the little stuff that we do, there's not as much work, but now we're sort of in a situation where it becomes a lot harder to do this without some real information. So in other words, we'd have to have a coordinate with our row and our column in it before we can do this. Now that doesn't mean that we need to do find a grape first. I'm sort of leaving it to last, I guess, because it's sort of the most interesting. But we know that if we've set up this coordinates thing that's going to hold our row and our column, well then we can just use that thing in terms of, get how far Oscar is to the grape, right? We can turn this into a method, even though it's really not a lot of work. It's, driving home the point that, let's see, get how far Oscar is to the grape. Move in the direction that makes Oscar closest. Okay. Okay, so in thinking about this, really with get how far Oscar is to the grape, there were two parts to that, right? We wanted to know both our change in our rows and our change in our columns. So again, we're kind of ending up with another piece of information. However, I don't see any problem that our coordinate that we've already created can't fix that. So public coordinates get distance, right? Because we want to find out how far away Oscar is from a thing. Okay, we know that we're going to, okay, so distance is just, oh, that's right, we don't need that. We want that. Wait, no, we do want this. I forgot about that. Well, you know what? Okay, this is cool. We'll just do an int because what we really want to figure out is just, so we know that if the difference in our rows is more than the difference in our columns, we're going to go that way. So we can sort of think about, right, because we really have two pieces. And there's nothing really wrong with that. It's fine. I mean, no, okay, it's cool. We'll just do it this way. So we have two pieces of information that we care about, so we'll define them here, right? I was giving it a little more thought than was probably necessary. Okay, so we have two pieces of information that we care about just in figuring out this whole distance thing, right? We care about how far away we are in rows and how far away we are in columns. And it's a good idea to assign stuff rather than leaving it blank. It would still be zeros anyway. And as long as we actually compute the correct answer, the fact that these are sitting here as 0 won't be a problem. But logically, if you think about it, you know, on your board with your rows and your columns, if the distance is both 0 rows and 0 columns, well, then it's the same square. And so then it's not too helpful. But so what we're going to do is we're just going to take in we're just going to take in two integers, right? Because we're going to do rows as one calculation and columns as a different calculation. That's it. Which this seems, well, you know what? This is probably a little heavy-handed. We don't even need to do that. Sorry. And you know, this sort of back and forth, hey, I need that, hey, I don't need that, maybe I'll do it this other way. It's perfectly natural, or at least it certainly feels very natural to me. So while it might seem random or capricious sometime to the external viewer, just understand that you can change your mind. You're not married to any particular way of doing anything at any particular time, as long as it works. So we know that the distance, right? So we were going to start with Oscar's position. So we have this method called getRow, which is something that I already did for you in a different class. That if you noticed at the top here where it says Oscar extends abstract player is something that I already wrote, and it's handling some other aspects of the game and players that you don't need to mess with. Like, it would add much more complexity for what you would need to be doing, and it really wouldn't be all that interesting. The actual being successful in the game as a character has to do with this getMove method. That's the only one that you need to do. But anyway, part of this boring stuff that I've already done on your behalf includes this method getRow. So by calling that, it always gives you your player's current row on the board. Similarly, you have getCall, which will always give you your player's position on the map in column. So we know that we have grape row, right? Because the coordinates of the grape are going to be stored in variable grape, and then we have just, here, this is, so getRow is a method, right? So we don't have direct access to our row, but because our coordinates can't ever change, right? Or at least we haven't provided any mechanism for them to change, and there wouldn't be any point to changing it because we're just going to create it and then we're going to use it. There's nothing, so there's really no danger here in saying grape row. There would be some more complicated code that I could write to make sure that it couldn't actually ever be changed, but it's more work than it's worth right now. So anyway, however, this is going to perform this stuff here, right? So all we're doing is we're taking the row of the player and the row of the grape, and we're going to subtract it out, and we'll get some positive or negative number, right? And then we're going to use the positive or negative later to determine, whether or not it's north or south or east or west. Okay, so this part of the code is now done. So now move in the direction that makes Oscar closest. All right, so we still have to do that. Whoops, let's cut that and put it back up here so it's in the right spot. Okay, so get how far Oscar is to the grape. So this is a little different because now we want to know like how long it's going to take Oscar to get there by each one of these. So because some of these values might come out negative, a negative value is always going to be less than a positive, even if it has greater absolute value. So we're going to compute the absolute values of these. Now remember that in here, if the absolute value, oops, well, actually we can just go ahead and snag this like we did before. Okay, this one does look a little more heavy-handed. So we will come in here and make another method just because it's nice to keep this short, right? If you can see all of get move in one screen, that's really great. So, and because all of this stuff is going to determine, which way we go, it's going to be char get. Let's see, we can't actually define, well, no, okay. This is going to get a little trippy. Here, we'll just do this. There we go. When I started to say get move, I was just trying to, be intuitive and give it a good name. We could actually have written another get move that returns a char that is public because it would take a different piece of information. And that's actually called its signature. In fact, I'll just show this off. If you're not going into programming, you really don't care. It's not gonna hurt anything. But what we're able to do, and again, we're gonna have some value just to let it compile really quickly, and then so in this case, we're going to be taking our distance and our call distance, and we're going to be feeding these two pieces of information into this get move. So we're going to have, and we'll just call them the same thing, just, because that might be a little easier on us mentally. So when I compile this, so we have public char, get move, row dist, int call dist. Now up here, we're asking for a different piece of information. So what that really means is even though there's two methods, both called get move, that return a char, that are public, this one takes different information. So Java can tell the difference between a call to this get move and then this call to get move because they take different information. So in this case, let's go ahead and say char move equals in, and then we can blow this away and say return move. So right now, this will compile. It's going to always give us north no matter what. And so I'm not really, so far like this, all this stuff is really going to be inside of here. And we'll just say, oops. There we go. Okay, so we've done that stuff. And then what do you think is going to be here? We're going to say, all right, so we're ultimately wanting our move out of this, right? This is going to tell us what our move is really going to be. So move equals get move row dist call dist. Bam. So we compile this, and this will function.